Thank you, Darren. So I'm very conscious that I stand between yourself and lunch, so I'll try and keep this as brief as possible. But thank you for the opportunity. As Darren said, my presentation is on active travel and mobility monitoring, if I can say it properly. And it's based on a case study of an innovative sensor-based video analytics system that was deployed in the city of Groningen in the Netherlands. So for those who don't know PDS, just a quick introduction to ourselves. So we're a transport systems integrator and solutions provider, and provide any technology from a control room system down to the roadside sensors and anything in between in terms of communications, etc. We're synonymous and known for providing high resilience, high availability systems into various markets, including ITS, but also into things like road tunnels, which are heavy in technology, but also into the power sector and in airports as well. And we've been established for around 35 years. And we're very much an engineering-driven organisation, and we're dedicated to understanding our clients' challenges and providing technical solutions to meet those. And we provide a complete range of services, from design through to capital project delivery, and then follow-on maintenance services as well. So there's been lots of industry challenges that have been mentioned in presentations earlier, and I won't go through them all, but I think we're all facing them, and they're one of the solutions to these challenges are around the use of adopting active travel and the associated health benefits from that. We can learn lessons from the Netherlands in terms of them leading the way in the deployment of active travel infrastructure and policies that are focused on livable streets and emphasis on pedestrians and cycling modalities. But how do we encourage and measure active travel? So a few bits of information around Groningen City. So it's the largest city in the northern Netherlands. And as part of this trial and project, they wanted to improve congestion in the city and gain a better understanding and insight into the adoption and behaviour of different active travel transport modes, particularly around the main streets of the city. And they wanted to be able to understand the different modalities that are used between pedestrians, cyclists, etc. The initial part of the project involved a single corridor through the city, but was then later expanded to include several routes. And overall, they wanted to try and improve the user experience, the road user experience within the inner city. So hopefully I've got a small video for you that will just explain the solution better than I can.
Cities are becoming more and more crowded. Cyclists and pedestrians are an important part of traffic users. But we know little of how crowded our streets are exactly and where people are going. Our innovative solution, the FlowCube system, provides useful insights. The system contains small sensors that provide real-time data in traffic movements, useful for monitoring inner cities with high accuracy. Each sensor measures exactly how many cyclists, pedestrians and vehicles pass by. It also uses key features to create a match code. Evidently, all privacy measures are observed. The match code is momentarily stored in a safe cloud and erased immediately afterwards. When traffic users pass another sensor, it shows the average travel time and which routes are chosen. This feature also works for motorised traffic. On a dashboard, traffic flows for crowd control and traffic management are visualised in real time. So, when it gets too crowded in an area, it's possible to warn or propose a quicker and less busy detour. The data can be linked to traffic management systems like MobiMaestro, which helps take targeted actions. Thanks to collecting traffic insights by FlowCube and managing crowds, you're able to make data-driven decisions to improve the infrastructure and keep cyclists and pedestrians safe.
Okay, so hopefully that gives you an idea of how the solution works. For the actual project, as I said, there were initially 6 locations and sensors placed across one single route, and then that was later expanded to 20 sites with one passing line per location, and each sensor would monitor 2 directions, both in and out of the city centre. And once established, there are approximately 2 million passages per week that were detected across the sensor estate. This slide just gives you a bit more information around the actual sensor itself and how it looks. And you can see on the video provided the detection area that's drawn in the purple box, and then the analytics that the sensor is using to identify the particular modes of transport, and you can see the boxes that are driven around. I should say that the image is pixelated just from to protect people's privacy perspective. It's not how the image appears from the camera's view. And here's a view of the camera located on in a city, and you can see it's quite discreet, deliberately designed that way to not look like a camera and be intrusive. So once you have all the data from the sensors, then there's a rich amount of data that's available and accessible through a dashboard, through a web interface for the user. I won't go in all the graphs, but I'll just explain a few. At the bottom left, you've got some of the journey times across one particular route on a daily basis. And it just shows that generally that's quite consistent, apart from on a Saturday, where there's congestion occurring and a lot longer journey time across that particular route. The purple graph on the top right, that's showing pedestrian and cyclist counts across different days of the week. And then the bottom right is again showing the counts of cyclists, and you can see that it is showing it through the day. So you can see at the start of the day there's a commute, followed by the return journey at the end of the day. And the 2 lines represent alert levels that you can set in the system. So if there's congestion occurring or a risk of congestion, then the alerts can be sent by the sensor to the user. So what were the lessons learned from the project? So through the initial trial period and into the extended project, the city were able to gain insights into how the road users and commuters, how they behaved and what was the split between different transport modes. They're able to see, as I just mentioned, variations across different days of the week and weekends. And also, it's worth saying that this project occurred during the pandemic as well. So obviously they saw a dramatic reduction in footfall and transport into the city, which has obviously risen back up in over the last few years. The sensors work well in poor weather conditions, such as in heavy rain, but there were some performance improvements that were made during the initial trial period. And part of this was due to issues caused by pedestrians being detected in a shop window. Sorry, I've said this the wrong way around. So mannequins in the shop windows in the city centre were being detected as pedestrians walking through the city. So that was optimised in terms of the field of view for the sensor. So that was addressed. And there were also some issues that were refined around single detections when there's a tree in the middle of the view of the sensor or a light column. So further developments for the project, there's subsequently more over the last year, some further sites have been added. So the system's continually been expanded. So the further 6 sites added around the university campus and hospital. The data that's been generated from the system is being used to help influence future projects and improvement schemes and services for the municipality. And they've also linked the system in as a new data source into their traffic management platform that they've got there to provide a new rich source of data and also to start to implement traffic plans across the city to improve prioritising active travel modes and public transport. They've also been able to create a behavioural change as well through the use, as you can see in the images to the right of the picture, with VMS signs that are dedicated to cyclists, and it's showing them which routes are available and which are more congested, and trying to encourage them down different routes through the city. And also, if you can see it as well, there's comparable journey times between if you're going in a vehicle or using cycle lanes, and just to compare the journey times there and hopefully influence the migration to cycling. So in summary, the solution provides reliable data on pedestrians, cyclists and other traffic modes, including vehicles. It's worth saying that the data remains owned by the local authority. I think we can learn from the Netherlands approach and how they've their policies over the last 30 to 40 years have encouraged cyclists and greener transport modes. And certainly the information has been useful for the municipality to be able to quantify and assess how new policies encouraging greener transport modes have succeeded or not, as the case may be. Hopefully that's been interesting to you. We're exhibiting upstairs, so if you have any questions, I don't want to stop you having your lunch, but please come and talk to us on our stand.